If two resistors with resistances R1 and R2 are connected in parallel, as in the figure below here, then the total resistance R measured in ohms is given by the following formula: 1 over R, which is equal to 1 over R1 plus 1 over R2. Now, if R1 and R2 are increasing at rates of 0.3 ohms per second and 0.2 ohms per second respectively, how fast is R changing when R1 is equal to 80 ohms and R2 is equal to 100 ohms? And then round your answer to 3 decimal places. Okay, so first things first, what we need to do is we need to know the following. We're given the fact that R1 is equal to 80 ohms, and we know that R2 is equal to 100 ohms. Okay, and so what we're going to do is we're going to substitute into our particular equation. So that means the equation that we have is 1 over R, which is equal to 1 over R1 plus 1 over R2. Okay, so what we want to do is we want to find out what is R. So in order to find R, we're going to substitute those values that we have that are given. So we have 1 over R, which is equal to 1 over 80 plus 1 over 100. Okay, so the next thing we want to do is we want to be able to combine these two fractions. So by combining those two fractions, we're going to get 1 over R with a common denominator of 8,000. And we know 80 times what's going to give us 8,000? Well, that's 100. And 100 times 8,000 is going to give us 80. So we know 1 over R is going to equal 180 over 8,000. Okay, let's reduce this. So we have 1 over R, which is equal to 9 over 400. And so in order to solve for R, we know that that's going to be the reciprocal. So that means that R is going to equal 400 over 9. Okay? So now what we want to do is, now that we found out what R is, now what we need to do is now differentiate this formula here. So for step 2, okay, we have the formula 1 over R, which is equal to 1 over R1 plus 1 over R2. Okay, and so we want to make sure that we can differentiate this. So technically, if we rewrite this with negative exponents, this is R to the negative 1, which is equal to R1 to the negative 1 plus R2 to the negative 1. Okay, now the next step is we want to differentiate with respect to t. So we end up getting negative r to the negative 2 times dr over dt, which is equal to negative r1 to the negative 2 times dr1 over dt, and then minus r2 to the negative 2 times dr2 over dt. And now let's rewrite this without negative exponents. So we're going to have negative 1 over r squared times dr over dt, which is equal to negative 1 over r1 squared times dr1 over dt, minus 1 over r2 squared times dr2 over dt. Okay, so the next step here is we want to isolate and solve for dr over dt. So in order to do that, we're going to multiply both sides of the equation by negative r squared. So by doing that, we end up with dr over dt on the left side of the equation. On the right side, we multiply negative r squared by both of these terms. We're going to leave the r squared, and it's going to be positive r squared because a negative times a negative is going to give us the positive. So we have r squared times 1 over r1 squared times dr1 over dt plus 1 over r2 squared times dr2 over dt. Okay, so now what we can do is now write in the given information. So the given information is the following. We know that from step number 1, we know that r is equal to 400 over 9. So we have dr over dt. So we know that r squared, so that means we need to take 400, square that, over 9 squared. And then we also know that r1 is equal to 80. And we know that r2 is 100. And we also know what is the rate. So the rate of dr1 over dt is given by the following. You can see here that r1 is increasing at a rate of 0.3 ohms per second. So we know that that equals 0.3. And we know that dr2 over dt is another increasing rate at 0.2 ohms per second. So now we can plug in our information. So we have 1 over r1, which is 80 squared, times the rate of 0.3 plus 1 over r2 squared, which is 100 squared, times that rate, which is 0.2. So let's go ahead and do that. So on our calculator, we know that we're going to take 0.3 times 1 and divide it by 80 squared. So 0.3 and then divide that by 80 squared, and then plus 0.2 divided by 100 squared. And then we're going to multiply it by 400 squared over 9 squared. So times, parentheses, 400 squared divided by 9 squared. And that gives us, and again up here it tells us to round our answer to 3 decimal places. So if we round it to 3 decimal places, we get 0.132. So it's going to equal 0.132, and that is ohms per second. And therefore we would say that R is changing at 0.132 ohms per second.